So this video will hope to explain the processes behind creating a dynamic visual graph of data. This data will be retrieved from the light levels of a photoresistor connected to the Arduino code. When the light level is strong, a higher value will be stored on the dynamic graph, and conversely, a weak light level will give a low value on the graph. First, let's have a look at the setup for this project. We need 3 jumper wires, a 1K resistor and a photoresistor. Simply, this gives a 5V power to the photoresistor via the black wire and feeds information to the analog pin 0 on the Arduino board via the orange wire. Now, let's look at the code to be uploaded to the Arduino board. Right, as you can see, the code does not look too complicated. The code declares 2 integer variables, sensor pin and val. The sensor pin is set to read analog pin 0 on the Arduino, and the val is assigned to a 0. There is also 2 methods, setup and loop. In the setup method, the code initializes a serial connection between the Arduino and the computer at 9600 bits per second. The loop method refreshes every 100 milliseconds, getting new information about the photoresistor light levels. The sensor pin will read the value got from the light sensor, and the variable val will store this value and send the information via a serial connection already initialized in the setup. Now let's have a look at the code for displaying this information in processing. I won't go into too much detail about this code as it will take some time, but essentially this draws the dynamic representation of the information in graphical form, which is in the form of a pie chart. This processing code reads the value of val from the Arduino code and draws it on the screen. If you remember, there is a loop method in the Arduino that constantly refreshes this value, hence the visual change when the applet is run. You will now see this in action in a few moments. Okay, to start this applet, all that is needed is clicking on the Run button in the processing IDE. As you can see, the applet appears after a brief moment. It displays the current amount of light received from the photoresistor. To test this, placing a finger over the light causes the graph to dip inwards. The reason for this is that the photoresistor is taking in less light, so a lower reading is sent to the graph. Now that is working perfectly, it is time to modify the processing code to make the graph look different. So the code has been modified. The size of the graph has been increased from 440 to 600. The frame rate has changed from 30 to 300. The stroke of the radius has also been altered from 2 to 5. The applet background color too has been changed to a blue color. The background of the graph has been changed to a green, and the stroke color of the data reading has been changed to a dark purple color. Let's see how this looks now. Just like before, the applet is working fine, but this time it's just over a third bigger. The radius stroke is 2.5 times thicker and is much faster as the frame rate was increased by a factor of 10. Also, quite obviously, the new colours are very noticeable. Right then, that's everything completed. This project was a success without any major hiccups at all, and thank you for listening.